Hello everybody, welcome to this video. This is the video for Module 15, which deals with solving equations. Particularly, we're going to focus on one-step and two-step equations to get started. We'll go through a few example problems and then hopefully we'll be good to go on the process for solving equations. So with that, I'm going to share my screen and we'll go ahead and get started. So solving one-step and two-step equations. Before we get into the examples, one thing I want to first remind you of is the kind of the three general rules that you follow when you are solving any equation, no matter how many steps that it has. The first rule is to remember that your goal is to get the variable by itself. Everything that you do in the solving process is with the goal of getting the x or whatever letter happens to be in your equation all by itself on one side of the equal sign. To do that, we follow rule number 2, which is you do the opposite operation as what appears in the equation. So if you have, for example, addition in your problem, what you're going to do is you're going to do subtraction to make that value, that number, go away in the goal of trying to get the x by itself. And then the final rule that we always follow is we always do the same thing to both sides of the equation. So if you add a number on, say, the left side of the equation, you add that same number on the right side of the equation. Or if you subtract, you do the same thing on both sides, multiply, divide, all of the basic operations that we follow. The reason you do the same thing to both sides is it keeps the equation balanced. It keeps both sides equal to one another. And so basically, following those three rules gets you to the point of finding the solution to the equation. Again, your goal is to get the variable by itself. You do that by doing the opposite operation that shows up in the equation, and you do the same thing to both sides. All right, with that, let's go through a couple of examples then to illustrate the process. Okay, so sample problem number 1. We have a one-step equation that we're going to solve. We want to figure out what x is going to be equal to in this situation. Okay, now the key thing to remember is in addition to our three rules that we follow when we're solving an equation, if you have multiple steps in your problem, you always want to follow order of operations, but you do it in reverse because solving an equation is basically the opposite process of simplifying or evaluating an expression. So when we're used to using order of operations when we're simplifying and figuring out what the answer is equal to, here we're working in reverse to figure out what one of the initial numbers is in the problem. So on the screen here, you'll see basically the steps that you follow when trying to solve an equation. If there is not a requirement to do that step, if there isn't that operation in the problem, or there's no need to do the simplifying or anything like that, you just skip over the step. So in this particular situation, you know, there's nothing really to simplify because all the like terms are already put together. There's no parentheses or anything like that. There's only the one variable in the problem that's showing up, so there's no need to get, or actually the variables are already on one side, so there's no need to do any work there. So then we come to the actual operations. What we do is we get rid of the add and the subtract next, and then continue down order of operations. So in this particular situation, what we want to do is we need to get rid of the plus 28 to get the x by itself. So again, the rule is you do the opposite operation as what appears in the equation. So what we're going to do is we are going to subtract 28. Okay? And again, we're going to do that to both sides of the equation to keep it balanced. On the left, when you take 28 minus 28, you end up with 0, and x plus 0 is just x. On the right, you end up with 35 minus 28, which is 7. Now, this is just a one-step equation, so we've just done the one step. That's really all there is to it. If you want to go back and check your answer, you can take the 7 put it in where the x is at, and see if, after doing order of operations, if both sides equal. So basically you're looking to check to see does 7 plus 28 equal 35. And in this case, it does. So we know that we've got the correct final solution, x equals 7. So one-step equations are pretty easy. Like I said, there's one step involved. It's just a matter of figuring out what that step needs to be to find the solution. Let's look at the next example. This time we're going to solve a one-step equation that involves multiplication and division. So again, on the screen, there's the reminder of the steps in order of operations in reverse that we follow. Here's our problem. So we want to think about, getting the x by itself. So we have to get rid of that timesing by 3. So in order to do that, we do the opposite operation. So we're going to, instead of multiplying by 3, we're going to divide by 3. And we do the same thing to both sides of the equation to keep it balanced. So we're going to divide both sides by 3. On the left, 3 divided by 3 is 1. And 1 times x is just x, so that gets the variable by itself. On the right, 36 divided by 3 is 12. And there's our solution. Again, this is just a one-step equation, so there's just one thing that we have to do in order to get the variable by itself and to solve the equation. If we go back and double check, 3 times 12 does in fact equal 36. So we know that we've got the correct solution. All right, so sample problem number 3 is a two-step equation. So when we look at the steps that are involved, now this is where these steps become a little more important because of the fact that we have a couple of operations in our problem. We have to figure out, which piece do you get rid of first? Do you get rid of the timesing by 2 or do you get rid of the -5? And again, we're following order of operations in reverse, so that's what tells us the order in which we go about getting the x by itself. So I'll start with my equation here. There's nothing to simplify. There's no like terms. There's no parentheses to distribute out or anything like that. So each side is as simple as it can be at this point. There's only the one term with an x in it, so the variable is already on one side of the equation by its in the process of getting it by itself. So now we're going to take care of addition and subtraction. And again, you do the opposite operation. So to get rid of -5, we're going to add 5. And we do the same thing to both sides to keep the equation balanced. So -5 and +5 gets us 0. And 0 plus 2x is just 2x. On the right-hand side, 11 plus 5 is 16. Now we're to a one-step equation where we need to get rid of timesing by 2. So we're kind of, again, working down our list of steps here. To get rid of multiplication, we do division. So on the left-hand side, we're going to divide by 2. And on the right-hand side, we're going to do the same thing, divide by 2 as well. On the left, 2 divided by 2 is 1. 1 times x is just x. So that's the variable that we want to get isolated. 16 divided by 2 is 8. And there's our solution. Now, as the problems get more complicated, it becomes that much more important to go back and check your work. So if we go back up to the original problem and put the 8 in for x, let's see that it balances out. So 2 times 8 is 16. 16 minus 5 is in fact 11. So that's our way of checking to make sure that our final answer is in fact the correct solution. All right, let's do one final example, one more two-step equation. So this time in our two-step equation, we have division and addition. So again, reminding you of the steps that we go through in terms of the order in which we work to get the variable by itself. We want to get rid of the addition first, because that comes on our list first when we're working backwards through order of operations. You do the opposite operation. So we're going to subtract 6 on the left. Then we're going to do the same thing to both sides. We subtract 6 on the right. 6 minus 6 is 0. So 0 plus the x over 4 leaves us with the x over 4. On the right, 15 minus 6 is 9. All right, now we want to get rid of division by 4. So to get rid of division, we do the opposite operation, which is multiplication. So we're going to times both sides by 4 to keep the equation balanced. On the left, the timesing 4 and the dividing by 4 cancel out to 1. 1 times x is just x. On the right-hand side, 9 times 4 is 36. And if we do a quick check of our work, going back to the original equation, plugging 36 in for x, 36 divided by 4 is 9. 9 plus 6 is in fact 15. And so there's our solution. So there you go. There is some examples of solving one-step and two-step equations. Hopefully the examples are helpful in illustrating the process that you need to go through. Just a couple of things to remind you of when you are solving the equations, especially ones that are, like I said, one-step and two-step. It can be easy to want to do stuff in your head, you know, and just kind of, you know, do the math really quick and not go through all the steps of showing the work involved. I definitely recommend that you practice solving these equations by showing those steps. That's going to make your life easier, especially when we get to the next level, which involves steps that, or problems that have more than two steps. Getting in the habit of showing the work, showing, you know, like when you're doing the opposite operation and things like that can really come in helpful when your problems are really complicated and they have a lot of steps involved that you're trying to work through. So as you practice these problems, make sure that you practice the steps. That's really going to help you out in the long run when it comes to getting good at solving equations and being able to follow the rules and work backwards through order of operations when you're solving. If you do have any questions on solving equations, please let me know. I'm happy to help out in any way that I can. Otherwise, thank you for watching the video. Good luck as you do the homework and get ready for the quizzes, and have a good rest of your day.